Whatever the quality of the aircraft, manufacturers of combat aircraft are doomed to constantly improve their products, otherwise they will quickly lose the trust they have temporarily gained from aircraft operators. General Dynamics does not deviate from this rule, and while the F-16A and F-16B Fighting Falcon fighters come off the assembly line of the Fort Worth plant in large series, the airframes of the very first copies are used for experiments with promising layouts. The reason these examples were not delivered to combat units is fairly obvious. Their equipment did not meet operational standards. Such is the case with the 5th and 3rd F-16A and F-16A, which were the first and second prototypes of the F-16XL No. 1 and F-16XL No. 2, respectively. The versatility of the F-16A was a pleasant surprise, appreciated by future foreign users who, if they followed the order, would not have to retrofit their vehicles, as was the case with the Lockheed F-104 conversion. However, the F-16A has been optimized for air combat, in which it remains outclassed, while for striking ground targets, it is outclassed by the MS Donald Douglas F-15A and F-15C. General Dynamics engineers, led by Harry J. Hilliker, investigated how best to overcome the disadvantage that separated the F-16 from the competition primarily in terms of range and payload weight. The modification program, called Scamp, was to convert the standard airframe by optimizing it for bombing while retaining as many of the original elements as possible to reduce production costs. In early 1980, General Dynamics requested 2 aircraft from the U.S. Air Force Weapons Systems Command, and this request was granted. On the other hand, this work received no funding other than that provided by General Dynamics, as U.S. Air Force officials concluded that the McDonnell Douglas F-15E Strike Eagle fighter bombers already fully met their wishes. The final design was chosen after more than 3,600 hours of wind tunnel testing was conducted in cooperation with NASA. The objectives of the tests were to determine the changes to be made to the fuselage design and the optimum wing shape. In March 1981, the 5th F-16A arrived in Fort Worth at the General Dynamics plant for conversion to the F-16XL variant. Leaving the plant on July 2, 1982, the very next day, F-16XL prototype No. 1, flown by James McKinney, made its maiden flight. During 63 minutes of flight, the first F-16XL, armed with 2 AEM-9 Sidewinder missiles suspended on the wingtips and 4 AMRAAM missiles, reached a speed of Mach 0.9, sustained a 3G overload, and flew at an angle of attack of 20 degrees. The first F-16XL is a single-seat aircraft with a Pratt & Whitney F-100 PW200 turbojet engine developing 10-810 kgf of thrust. Compared to the F-16A, consists of a triangular wing with a double sweep change of the leading edge, a wingspan of 9.88 meters, and an area of 60.1 square meters. The outer portions of the wing consoles have deflectable noses and ailerons, while the inner portions of the wing consoles are equipped with elevons. The aluminum alloy multi-blade structure received graphite fiber cladding, saving 260 kilos compared to aluminum alloy cladding and facilitating the fabrication of very complex shapes. The F-16XL wing accommodates 2,220 kilos of fuel, 4 times more than the F-16A wing. The 16.51-meter-long fuselage was lengthened by adding a 0.76-meter section behind the cockpit and another 0.66-meter section just forward of the keel, allowing an additional 840 kilo of fuel to be stored in the fuselage. Despite these modifications, the airframe of the first F-16XL was made from 72% of the F-16A airframe, and since the cockpit, electronics, and power plant were identical to the basic version, the F-16XL actually utilizes 87% of the F-16A design elements. There were some problems with the F-16XL landing gear, as the maximum weight with load increased by 5,700 kilotons, and the landing gear had to be replaced to complete full load testing. The F-16XL's integrated armament remains the same, and consists of a single 20mm M61 automatic cannon, while the 6,800 kiloton external load can be distributed across 16 underwing mounts and 1 under-fuselage mount. Particular attention was paid to the placement of the combat load so that the aircraft would not lose all its flying qualities due to the enormous drag created by the bombs in particular. The solution adopted is to suspend them as close to the fuselage as possible on very short pylons and to align them in such a way that the first bomb conceals the subsequent ones and that their overall arrangement provides a useful effect of mutual interference. The first F-16XL prototype was delivered to Edwards Air Force Base on July 17, 1982, where the first test program was initiated and completed in September, with a total flight time of 53 hours. During this time, the flight regime area was gradually defined. The aircraft almost reached Mach 2 speed and climbed to an altitude of more than 15,000 meters. First of all, however, the aircraft demonstrated the advantages of the new payload arrangement, flying easily at Mach 1.2, with 12 225-kilogram bombs, and accelerating amazingly with 4 AMRAAM missiles and 2 AIM-9 Sidewinder missiles. On 24 August, a very important step was successfully accomplished. 12 bombs were dropped almost simultaneously in straight flight at an altitude of 4,000 meters and at a speed of Mach 0.75. Except for some difficulties in sealing the leading edge of the flap, the airplane showed excellent operational readiness. The only real problem, identified during static testing and confirmed by flight tests, was that the rear wing spar failed when 86% of the load limit was reached. This aluminum spar had to be replaced with a stronger but heavier steel spar. On October 29, 1982, it was the turn of the second prototype to take to the air for the first time, with a crew consisting of Alex Wolff and James McKinney. The aircraft reached an altitude of 9,000 meters, accelerated to a speed of Mach 1.4, and sustained an overload of 4G during this flight. Unlike its predecessor F-16XL No. 1, the second prototype F-16XL No. 2 differs significantly from the basic fighter F-16A turbojet engine General Electric F-1001 DFE, with a thrust of 13,000 kJf. It should also be noted that the F-16A fighter was a single-seat fighter before being converted to a two-seat prototype F-16XL Year 2. The results of comparative tests of the two prototypes are not yet available, but in any case, General Dynamics at a lower cost to create an aircraft that offers significant advantages over its predecessor both in terms of range and payload. At the same time, the takeoff and landing characteristics and even the legendary maneuverability of the Fighting Falcon fighter were improved. If General Dynamics' efforts lead to the adoption of the F-16XL into service, the production version will be designated the F-16E. Compared to the F-16XL prototypes, the production F-16E fighter bomber will receive an improved APG-66 radar and avionics, allowing it to strike ground targets in all weather conditions, as well as all the equipment modifications that will be made on the F-16C fighter.